This is Precalculus, lesson 4.6. I'm starting on page 307. So the title of this lesson is The Fundamental Theorem of Algebra. The fundamental theorem of algebra says that if I have a polynomial, then whatever the degree of that polynomial is, I have that many solutions in the complex system. So they can be real or they can be imaginary. All right, so if I have a 5th degree polynomial, then I'm going to have 5 solutions, not necessarily zeros, but 5 solutions in the complex system. I may have 2 imaginary and 3 real. All right, so we're putting together the complex lesson, lesson 5, and the previous lessons. All right, so let's look at example 1 on page 308. It says find a polynomial given its zeros. So we want a polynomial of the 5th degree whose zeros are 1, -2, and 5. 1 is a zero of multiplicity 3. And it says f of 2 is -24. All right. So we'll write it f of x equals, we don't know what the lead coefficient is. That's what we're going to solve for. All right, but we know if 1 is a 0, then it's x minus 1. The multiplicity is 3. It crosses the x-axis. It didn't change the multiplicity for -2. So that's just going to be x plus 2 because it's x minus -2. And this would be x minus 5. All right, so when I plug in 2, I want the result to be 24. All right, so I'm going to plug in 2 every place that I have x. I'm going to set it equal to -24, and then I'll only have one variable, a, so I'm solving for that lead coefficient. So it's going to be 2 minus 1 cubed times 2 plus 2 times 2 minus 5. So -24 is a. 1 cubed is just 1. I don't even have to write that down. 2 plus 2 is 4. 2 minus 5, that's -3. That's -12. When I divide both sides by -12, the value of a is 2. So that's my lead coefficient. So I could write, here's my polynomial. It's 2 times x minus 1 cubed times x plus 2 times x minus 5. And you don't have to multiply all that out. All right. Now, example 2 on page 309. All right. It says find the zeros of this polynomial. F of x is x squared minus 6x plus 13. I already know I can't simply factor. There's no factors of 13 such that we add them in, we get -6. So I'm going to the quadratic formula. All right, so x equals the opposite of b plus minus the square root of b squared, which would be 36, minus 4 times a times c all over 2a. All right, so x is 6 plus minus 4 times 13. I'm pretty sure this is going to give us a imaginary number. It's 36 minus 52. So 36 minus 52 under the radical. That's the square root of -16 over 2. X equals 6 over 2 plus minus square root of 16 over 2 is 4i over 2, and that can be further simplified. So x is 3 plus minus 2i. There are no zeros, right? There are only solutions. So there are no real zeros for that polynomial. All right? Now look at example 3. It says find a polynomial with real coefficients whose zeros include the numbers 2 and 3 plus I. Well, I know if 3 plus I is a solution, then 3 minus I is a solution. All right, so my factors would be x minus 2 times x minus 3 plus I times x minus 3 minus I. Let's eliminate the parentheses inside. Do I want to? I think I want to eliminate the parentheses. All right, in here. So that's x minus 2 times x minus 3 minus I times x minus 3 plus I. All right, so let's FOIL these. Well, not FOIL, distribute. We'll do x minus 2 last. All right, x times x is x squared. X times negative 3, negative 3x. That's plus xi. All right, now we're going to do the negative 3. Negative 3 times x is negative 3x. Negative 3 times negative 3 is positive 9. Negative 3 times I is negative 3i. Now we'll distribute the negative I. So it's going to be negative xi positive 3i minus I squared. I squared is negative 1. So let's simplify what's in here first. X minus 2. We only have one x squared. What about what cancels? This cancels. Our 3i cancels. All right, so x, in terms of x, we have negative 3 and negative 3, so that's negative 6x. Then we just have positive 9 minus a negative, so it's positive 10. Okay, you're always going to get that type of a polynomial. Now we're going to distribute. We'll distribute this binomial. So first we'll distribute the x. So we have x cubed minus 6x squared plus 10x. Now we'll distribute the negative 2. So that's negative 2x squared plus 12x minus 20. And we add our like terms. So that's plus 22x minus 20. That will be your final answer. All right. So two more examples. All right. Now, example 4. Example 4 says completely factor a polynomial over the real numbers. All right, so that makes we're only going to have real numbers. All right, so we're given it's x to the 4th minus 2x cubed minus x squared plus 6x minus 6. And we're given that 1 plus I is a 0. So x minus 1 plus I, that would be a factor. And so would x minus 1 minus I be a factor. All right, so I'm going to multiply those. First, I will eliminate the parentheses on the inside. It's minus 1 minus I, minus 1 plus I. Now distribute. I'm going to distribute the x first. I have x squared minus x plus xi. Okay, I'm going to write these under each. So this is going to be minus x, another minus x. That's going to be plus 1. And that's going to be minus I. I'm going to distribute the I. It's going to be negative xi. It's just easier for me to see it this way. That's going to be plus I. That's going to be minus I squared, which is going to be plus 1 because it's a negative 1, right? So we end up with x squared minus 2x plus 2. All right, so that's going to be one of our factors. So I'm going to write this over here. X squared minus 2x plus 2. And I'm going to divide this polynomial by this to get a smaller polynomial. I'm going to have a second degree polynomial. Can't do synthetic division because it's not a linear term. All right, x to the 4th divided by x squared, that's going to be x squared. Then I multiply, that's x to the 4th minus 2x cubed plus 2x squared. When I subtract, it changes all the signs because that negative has to be distributed. So my x to the 4th and my x cubed term cancels out. I end up with negative 3x squared. I think I'm going to bring down all the rest of the terms because I think maybe, we'll see. Maybe this will be it. So I should have, because I know that that's 0, I should have a 0 as my remainder. So this is going to be minus 3 is what I think. Minus 3. This is going to be minus 3x squared plus 6x minus 6. Yeah, and I have a remainder of 0. All right, so we know x squared minus 3 is going to be a factor. All right, but can I factor x squared minus 3? Is it real? Yes, x is going to be plus and minus the square root of 3, right? My 0 is x is going to be plus and minus the square root of 3. So we've never done this before, but you actually can. You can write the factor as x plus square root of 3, x minus square root of 3, because those are real numbers, right? And that's what it asks for. And then your last factor would be this, x squared minus 2x plus 2. And that is completely factored. You cannot factor this any further over the real number system. All right. Example 5. Last example. It says completely factor. Wait, it's not the same one. Okay. X to the 4th minus 5x cubed plus 4x squared plus 2x minus 8 over the set of real numbers, and then over the set of complex numbers. All right, so we begin with our rational 0 test. Factors of 8 over factors of 1. So these are possible zeros, all right? Possible rational zeros are plus and minus 1, plus and minus 2, 1, 2, 4, plus and minus 4, plus and minus 8. All right, let's do 1 first. Let's do 1. So that's 1. I'm doing positive 1. All right, I'm going to see if the remainder is going to be 0. Positive 1. That's going to be 1 minus 5 plus 4 plus 2 minus 8. No, that doesn't work. So positive 1 doesn't work. I'm going to write over here. Does not work. Let's try negative 1. Negative 1. That's still going to be 1. That's going to be 2 negatives. So that's going to be plus 5. That's going to be plus 4. This one's going to be a negative 2, negative 8. That works. All right. So negative 1 is a 0. So x plus 1 is one of my factors. I'm going to do synthetic division to make it smaller. Negative 1 is one of my zeros. 1, negative 5, 4, 2, negative 8. Bring down, multiply, add, multiply, add. That's negative 10. That's negative 8. That's 8. That's 0. So now we have x cubed. I should just write that down. X cubed minus 6x squared plus 10x minus 8. I'm going to erase that in a minute once I find another 0. I don't think 2 works, but I think 4 works. All right, you can try all these, but let's just try positive 4. I'm going to need my calculator. All right, so 4 cubed minus 6 times 4 squared, which is 16, plus 40. I know what that is. 40 minus 8 is 0. So positive 4 works. So another is going to be x minus 4. I'm going to do synthetic division. Positive 4 works. I'm going to make that an x squared. And then I'm going to the quadratic formula. Bring down, multiply, add. That's negative 8, positive 2, 8, 0. So we end up with x squared minus 2x plus 2. I think that is a complex number. That's what I'm thinking. And so we'll use the quadratic. X equals the opposite of b plus minus the square root of b squared. 4 minus 4ac all over 2a. So here's my factors so far, all right? So it's going to be 2 over 2 plus minus. It's going to be 4 minus 8, which is negative 4. The square root of negative 4, which is 2i over 2. So it's going to be 1 plus minus I. All right, so here's my factors. It's going to be x minus 1 plus I times x minus 1 minus I. All right?